Hi, and welcome to the pre-lunch session. I'm going to talk today to you about how, a little bit about the history of how the image and the stereotypes of the software developer came about. And yes, you are in the future of IT track, but as you all might know, that sometimes it helps to look at history to then think about the future. And so in the second part, I'm going to talk a bit about how this image is still a big factor in holding us back from becoming a more diverse workforce, which is something that sometimes seems a lot more futuristic to me than self-driving cars and things like that, because our progress there is so slow. So I am a programmer. Have been programming for about 15, 16 years now. I've been doing it for about 11 years professionally, and fortunately I still get to code almost every day because I'm fortunate enough to work for a company who believes in coding architects and tech leads. And I'm assuming that a large part of the audience also would say that they are programmers or they work with programmers. And I personally try to complete the sentence or this definition, what is a programmer, quite a lot in my day-to-day life. For example, when I'm involved in recruiting and to hire new programmers for the company I work for, or when people ask me what I do for a living, but also in terms of my identity, because I really love my job, so it's a big part of my life. So I've been thinking about this a lot over the past 15, 16 years. What does it mean to be a programmer? But if we went outside on the street right now, maybe on Alexanderplatz, and asked people what a programmer is, maybe these images would pop into their heads. More the inventors and entrepreneurs in tech. Although at least one of these guys is not even a programmer as far as I know. Another image that might pop into people's heads is this one of kind of the hacker wizards, the geniuses who can access a terminal by cracking polymorphic algorithms, apparently. I've never done that, but so I don't think that this is representative of the vast majority of software developers, and I would go out on a limb and assume that most of you here in this room would not identify with this. So I turned to history, and I learned a lot about the history of our profession and how it first came about from this book, The Computer Boys Take Over. It's written by a computing historian. His name is Nathan Ansmenger, and he talks about a lot of stuff in the book, like, for example, how the discipline of computer science first came about, how they named it, how computers and software first started disrupting businesses, how the first explosion of languages happened. But what I want to summarize for you a little bit is about how he describes our profession, the origins of our profession. So a reasonable place to start is then with the first programmers, right? But we already hit a little bit of a wall there because I entered First Computer into google.com and Erster Computer into Google Germany, and you actually get different results. So on google.com, the first result that comes up is the ENIAC, and on the German Google, the first result is Konrad Zuse's Z3. So what do you do? First programmers, those that programmed the Z3 or the ENIAC. But I'm showing you this because this is actually a reminder that most of the sources, most of the information I will present to you in this talk is actually from US American sources. A few UK sources, actually. I still think that's very valid because the US tech industry has a huge impact still on the global industry and especially the culture. This is just a reminder when you interpret what I tell you that this is very much from the US perspective, because I'm going to start with the first programmers of the ENIAC. And they are sometimes called the ENIAC Girls. I prefer to call them the ENIAC Women. And they've been in the media more and more over the past few years, I feel, so a few of you might have heard about them. And the more I learned about them, the more fascinated I became with them. And I want to show you a short excerpt of an interview with a woman called Jean Bartik. She was one of the 6 women who are generally called the ENIAC women. And what they did is they wrote a program for the ENIAC that could calculate weapons trajectories. And that was something that they would usually do with pen and paper, and I actually don't know what other help they had, but just sitting in a room, a group of women calculating these over hours, and they wanted to write a program to have the computer do that. And I'm going to show you this video, and it's from the Computer History Museum's website. So let's see if the sound works.
Betty Snyder and I, from the beginning, were a pair. And I don't know many of you work technically, but I believe that the best programs, the best design, and all this stuff is done by pairs, because you can criticize each other and, you know, find each other's errors and use the best ideas, and it really works very well. Later on, I have thought about why did Betty and I become so successful? And we were successful. And I think it's because we were finishers. Because most people like to do the fun part of a design or a program, but they hate doing the nasty little details that usually take more than the middle design. And so you have to take care of everything and think of everything so that it works. Well, I was good at it, but Betty was even better than I am. She was fantastic. The smartest thing we did was to have Marlon and Ruth calculate a trajectory exactly the same way the ENIAC did it, you know, ad time by ad time. Well, this is the document that made people respect us. Because of those 18,000 vacuum tubes, we could find the one that wasn't working in a very few minutes with that. And we were never, people never recognized, they never acted as though we knew what we were doing. I mean, we were in a lot of pictures, but they never asked us anything. Well, we did all the programming for it. I mean, it was absurd.
So I really recommend that you also watch the full version of this. I think it was like a 45-minute long interview, but she's actually a very nice storyteller, very entertaining, and tells some interesting anecdotes from her time working on the ENIAC and also after that. Some stories around John von Neumann. You might have heard of the von Neumann architecture, and so it's quite entertaining. But from this excerpt, actually, there were two things that really struck me. The first one, you might have noticed right at the beginning of the clip, she basically talks about pair programming. And these women didn't have any role models to look to how to do this job, and they decided the best way to do it would be to work together and use each other's ideas and criticize each other. And it took us decades, it took us 60 years or so until this became a general practice in our industry and got a name with pair programming, which probably came about mostly with Kent Beck's book on extreme programming. And the second thing is that when she talks about this document that those other two women wrote, that wrote down ad time by ad time what the ENIAC was supposed to do. That's another one of those things that we take for granted today. We constantly compare what we expect with the actual results to test and to debug, and we don't even think about that anymore. But again, these women didn't have anybody to look at, like what is the best way to do this, to debug this, and they already came up with that. Let's have what we actually expect to come out of this and then compare it to what the computer does when something goes wrong. So I found that amazing. So here they are. I think these are actually Jean Bartik and Betty Snyder Holberton that she talked about programming. That's Jean there, I think. And as you might have known, and as you can see here, it was a much more mechanical, almost switchboard-like process at the time. And it was considered much more handicraft and science and not very intellectual. And the women who did this at the time, the term programmer wasn't even around yet, and they were called computers or operators. And another thing that Ansmenger mentions is that the term coder was also around, and it was very much associated with this non-intellectual handicraft work and also associated with the female gender. And Ansmenger says in his book that for years after that, later, male programmers tried to distance themselves from this term because it was associated with those things. So at this time, there were very high hopes for computers, very exciting times, so they finally had electronic Turing-complete computers and were figuring out how to make them better and faster, but nobody was actually paying much attention to software yet. They thought that would just be something on the side, you know, some engineer would come up with a flow chart and then somebody would put it into the computer. Like Stephanie Shirley says, she's this amazing woman who founded one of the first UK software companies in 1962. And she says software was given away free at the time with hardware, and nobody would buy software. Certainly not from a woman, is what she adds. But it soon became clear that the challenge of software development actually had been really underestimated. So they started to realize that programming is hard, and a lot harder than they thought it would be. So here's a short quote from Maurice Wilkes, a British computer scientist. So he realized it was basically impossible for him not to make errors, so he would probably spend the rest of his life finding those errors in his own programs. And also in the press at the time, in the 50s and 60s, there were a lot of stories going around, like that of the Mariner 1 probe that they tried to send to Venus, and it steered off course and they had to destroy it. And there were all these urban legends going around why that happened, and one of them was that there was a dot instead of a comma in a Fortran statement, and that's why it went off course. So it's very much debated if that was actually the reason. There are some other theories out there, but it just shows the stories out there that made people believe that programmers had to be really, really good to do their job because it was so easy to make errors, and then they might be really expensive. So the view of the programming in the 50s and 60s was that of kind of magic or black art. Also, of course, at the time, every computer was different, so every programmer had to figure out again with a new computer how to use it, so that made it even more mysterious how to do this job. Also, they believed that programmers are born, not made, because they couldn't figure out yet, it was this totally new profession, they couldn't figure out what are the skills that you need, because there was no computer science discipline at the university, so they just had to hire people and train them in this, but who do you hire for this? So they decided, oh, you have to be born for this because it's so magical, so we can't, it's hard to really make you a programmer. And this is quite a famous quote by IBM. When a programmer is good, he's very, very good, but when he's bad, he's horrid. And you might still hear that today, right? So people believed that you could only use the really best programmers because it was so error prone. Then they also couldn't really figure out what the skills were that you needed, so they believed you have to be born to be a programmer, and then you have to be identified somehow. And at the same time, the demand was rising rapidly, so they needed more and more programmers. And this was around the time that the term software crisis was first coined in the 60s, which describes the situation where we need a lot of good people to do this job, but there's just never enough supply. And you might argue that the software crisis has been going on ever since then because we're still in that situation today. So how did they try to hire these magical beings at the time? Here's one example. This is an ad that was posted by IBM in the New York Times in May 1968. And its title is, "Are You the Man to Command Electronic Giants?" And then it goes on, and they're looking for candidates who enjoy musical composition and arrangement, people who like chess, bridge, or anagrams, or simply possess a lively imagination. And they received exactly 7 replies and considered that an excellent return on investment. So another thing, apart from these kind of quirky ads that they came up with, was aptitude tests. So a number of tests that filtered for traits that people at the time thought were essential to good programming, like logical thinking and abstract reasoning. And in 1962, about 80% of businesses who needed to recruit programmers used some form of aptitude tests. Half of them used the IBM Pat, the Programmer Aptitude Test. And in 1967 alone, 700,000 people took this IBM Pat. And that test had 3 parts. The first part was that you had to complete a number sequence, series of numbers, what's the next one? The second part was kind of geometric comparisons, so which shape fits into this group of shape. And the third one was kind of word problems, like in high school mathematics. So very math heavy, actually. And if you ask yourself now, if the scores of these 700,000 people, if they actually corresponded to their performance as programmers later, we don't know. Because most companies didn't even check. And those who did, they didn't really find a correlation. But some thought that aptitude tests were not enough, so they also turned to personality profiles. This is from the title page of a paper from 1966. It was written by 2 psychologists. And the title is A Vocational Interest Scale for Computer Programmers. I actually had to look up this word, vocational, when I first read it. So it's kind of, in German, it's kind of Berufung. Yeah, so when you go to a job center as a young adult and say, okay, these are kind of the things that I like, what do you think would be a good job for me that I would be happy in for the rest of my life? And so this was the personality profile they came up with for programmers. And it was close to engineering and chemistry, not even that close to physics and mathematics. There was a slight correlation with musicians, actually. But otherwise, it was pretty similar to white-collar work. And a few things that these two gentlemen, Mr. Cannon and Mr. Perry, decided about programmers was that they're crazy about puzzles. They tend to like research applications and risk-taking. They dislike routine and regimentation. I don't know if any of you recognize yourselves in this. But then they came up with one characteristic that was quite unusual, and it's actually in no other, as far as I know, in no other profile, and that's that they don't like people. So they said programmers prefer to work with things rather than people. They don't like to interact. And they accompanied this whole thing with these like kind of ridiculous cartoons. I don't really know why, if they weren't taking themselves seriously, or so in the up top left corner there is the guy who likes puzzles, and then there's the risk taker in the upper right corner, the guy who likes research applications, and in the bottom right corner here's the grumpy guy who doesn't like people and is a smoker apparently. I don't know if all smokers don't like people, I'm sure that's not true. So we're laughing about this, and as I said, I was a bit confused that they had these cartoons because it seemed like it wasn't really serious, but I want to tell you a bit about the context in which this paper was written. The authors were paid by a company called SDC, and SDC at the time was hired by IBM to work on a huge military project, the SAGE project, the Semi-Automated Ground Environment Air Defense System. Like so many early software and computer projects, it was a military project. And it was one of the largest software projects at the time. And SDC in 1956 employed 700 programmers. To give you a context of that, that was about 3/5 of the available programmers in the US at the time. And then 5 years later, they had hired 7,000 more programmers. So they say of themselves that they trained the industry at the time. And a long time after that, you could, in a lot of IT departments in the US, you could still find at least 1 or 2 alumni from this company. So, surprise, 700,000 individuals just in 1 year took the same test to determine if they would be hired as programmers. And the company who says of themselves that they trained the industry subscribed to a personality profile that included the trait that programmers don't like people. And Ensmenger actually concludes in the book that these hiring practices resulted in a primary selection mechanism for antisocial, mathematically inclined males. If you remember, the Pat, for example, was very math-focused. And therefore, those types of people were overrepresented in the programmer population, which in turn, again, reinforced the popular perception about what the job was, and then maybe put some people off and attracted other people, so it kind of self-perpetuated itself. And I have to say, he makes a pretty good point. So I want to fast forward now from the 60s, about 30 to 40 years, and give you some quotes to read again. So these quotes are from the late 90s, and you can see this theme of, this belief of you have to be born to be a programmer is still actually quite present. And these and other quotes really resonated with me, and they are from a book called Unlocking the Clubhouse by Jane Margulis and Ellen Fisher. And what they did is they put together a group of computer science students at Carnegie Mellon University in the US, and conducted interviews with them over the course of about 4 or 5 years, 1995 to 1999. and it was about a 50-50 gender ratio. And they asked them questions like, why did you choose to go into computer science? What motivates you? How do you feel at this moment in time? Or for those of them who dropped out over that time, they asked them, why did you drop out? Why did you stop doing this? And there are lots of quotes in here that can give us an idea of what the image in our heads of programmers is today, even programmers themselves. And here are two more. These quotes are not just from women, by the way, also from men. But sometimes this affects us a bit more because we already stand out a little bit like a sore thumb because we look different. So what these people were experiencing was that they actually started off with computer science, were really excited about it, and then they saw these other people around them with this eat, sleep, code, repeat attitude, and they thought, okay, so they're really passionate about this, so I'm not that passionate. I think I'm more balanced and I enjoy this, but it's not my life. So they were starting to think, maybe I don't belong here after all because I don't seem to be as passionate about this as other people, and they dropped out. And there's a really interesting exchange between two computer science high school teachers described in the book about what we expect passion to look like, and I would like to quote that for you. It happens to be a male teacher and a female teacher. And the male teacher starts off with an email saying that he comes across a lot of boys in his classes who really love computers. And several parents have told him that their sons would be on the computer programming all night if they could. And he says, I've yet to run into a girl like that. They look at me funny when I talk about programming as fun. And then the female teacher responds, and she doesn't respond with reasons why girls are just different than boys or things like that. But she says that she calls out what she thinks is this misassumption, and one that she also sees in her students. It's that we're looking in the wrong places or not enough places for signs of why you might be interested in computers. She talks about herself and says that when she started, she really loved programming when she learned it at school, but that didn't mean that she stayed up all night doing it. But she still loved it. And girls may show their love for computers and computer science very differently, but we're only looking in one place. So if we're using a single model to identify potential programmers, we will miss many potential students. So do we also have a scale in our heads and don't even realize it? And what does it do when we're interviewing candidates, or when we're describing to other people what our job is like, or when we're thinking about what we have to do to get the next job, maybe have 50 GitHub projects up and running and stuff like that. But also, what might it do to some people's identity? There's a blog post on Medium by a woman named Erica Joy Baker called The Other Side of Diversity. And I think it's about 2 years old, and it was really eye-opening to me when I read this. It describes what effect the lack of diversity had on her as an African-American woman working in the tech industry for about 10 years, sticking out like a sore thumb all the time, kind of low stress level continuously. And a few quotes from this text are, I continue to lose myself for the sake of being included amongst my coworkers, and I feel like I've lost my entire cultural identity in an effort to be part of the IT culture. And the caption there actually says, at work, wearing the uniform. And she's talking about unisex t-shirts, jeans, and sneakers. So, and she only realized this after 10 years of working in the industry, that she had been adapting to what was around her to fit in, and had actually lost her own identity through this. So this is a really good reminder why diversity always has to come with inclusion and inclusivity, words that have been popping up a lot more over the past 1 or 2 years. So fortunately, it has never been this bad for me, but reading her story also made me think about what my journey has been in IT and reflect on that. And I realized that I've often tried to just emphasize those parts of me that fit the image in my head and also what I thought was around me better, and just stayed more quiet about the ones that don't. For example, the many times that I've sat at a dinner table with all my male colleagues talking about their first computers, and I actually started programming when I was 22, I think. So I thought, oh, my first computer already had Windows on it, and I played Tetris, and so I could never join into those conversations. But on the other hand, I'm just a bit louder and more alive when I can talk about how I love science fiction and fantasy, because that seems to fit right in the mold. So before I finish, I want to ask you for a few things. The first one is, don't think the status quo is just natural. Oh, boys just like computers more, so that's why this is what it is, and it's going to continue like that. For example, something that I've always wondered about is why such a majority of programmers seem to like science fiction and fantasy. So where does that inclination come from? What is that correlation? I actually had discussions about this over drinks. And after reading these things, I realized, oh my God, there's no natural link at all. It's just us hiring ourselves over and over again, and then people self-selecting themselves into our group because they are similar to that, or not deciding to join us because they're different from what they see on the surface. So don't let a few guys in the 60s still determine who we hire and how people perceive us. The second thing is stop acting so surprised. I don't know if who of you has ever said, or has it said to them, sentences like, oh, you don't look like a programmer. It's a small thing, but when you're somebody who already feels like you stick out, like you have to prove yourself because your assumed competence level is different from people around you because you look different or have different interests, and you hear this over and over, then this can actually have a significant cumulative effect that you start believing, oh, maybe I do not belong here. And this is a phenomenon called microaggressions, and there are some really good articles out there that I recommend you read. One of them is this one. I'll give you a way to get to all these sources at the end. So, and part of this is also just to avoid incredulity. Like, what, really? You don't know this, or you don't know the difference between Star Trek and Star Wars? Just be happy, that they don't, because then you can explain it to them. That's awesome, right? So another little story, maybe I had a conversation with a journalist once, and he was doing a documentary about programmers. And it was at an event, and he asked me, so what do you do at Thoughtworks? Did you organize this event? And I said, no, I'm a software developer. And he said, oh, wow, cool. So does that mean you also write code? Or I was like, oh, you're doing a documentary about programmers. You should know what they do. Yeah. And lastly, I've said it a few times over the course of this, challenge your image of the real programmer. For example, let go of the notion that only people who spend every free minute programming can be good at this. Because let's face it, no amount of time spent doing this in our free time can actually get us up to speed on everything we have to deal with today, with things like you have to do ops on top of dev, microservices, poly everything, own your craft, write better tests, get better at interacting with people. Like one single person cannot do that. So it's all about It is magic indeed, just very different from the one that they thought it was in the 60s. So real programmers for me are those who know that they cannot do this all by themselves and create an environment where everybody embraces cooperation and doesn't make each other feel stupid and work together instead of pushing for rock stars and the genius programmers. And an environment like this might even be more attractive to new pools of people that we haven't even been tapping into in recruiting. So that, a truly diverse workforce without contempt culture is the future of IT to me, but again, it sometimes seems less realistic than machines taking decisions for us. So I summed all of this and a little bit more up in an article that my colleague Martin Fowler was nice enough to put on his website. That's the link up there, and you can find all the resources that I mentioned in the talk below that article as well, and also a link to the video. And we have 2 copies of the Unlocking the Clubhouse book at our booth, at the Thoughtworks booth, and it's part of the sweepstakes that is being done at GOTO. And that was all. And please give me some feedback and rate the session. And if anybody has questions, this is a pretty small room, so if you feel like you want to go out for an early lunch, feel free to do so. But if you have some comments or questions, maybe come up front and we can have a little discussion. We still have 15 minutes before lunch officially starts, so I would love to have some conversations about this. Thanks.
Okay. So, thank you very much for the talk. I think diversity is really an important question, an important issue. And I was wondering whether IT can even help with, for example, giving advice for meeting better solutions in fitness diagnostics. Imagine a toolkit, imagine a software that somehow rates an applicant to a job position, not by prejudice somehow, but based on a little bit algorithms and machine learning and whatever, so that the decision will be a little bit more accurate. Is it a thing? Is it a way to solve this or to move towards this diversity?
It's super hard, right? I don't think we can ever do this objectively, and also maybe doing this totally objectively at this point in time with the demographic makeup that we have might actually not even solve the problem, because we have to go through a transition time now where we actually maybe favor becoming more diverse over some other things. But there is something around standardization, I think. So not algorithms maybe, but standardization. For example, currently at Thoughtworks, we're thinking about moving, not accepting resumes anymore, but having a standard set of questions that we ask people that they can answer, so it becomes a bit more comparable, and it also gets rid of some of the biases that we get that we don't even want just by looking at the resume. Like in Germany, we still have pictures on them, right? So we still get in Germany a lot of resumes with pictures. Then you look at maybe if you're a stickler for form, then you see something that they formatted in the resume that you don't like, and it's a little thing, but all those things are your first impression. So there's something around standardization, I think, maybe that can get rid of some of those biases. But yeah, I'm very skeptical of algorithms and machines deciding that for us. Yeah, but it's super hard. Yeah. I think you.
Hi. So my question was something similar, but I would like to, so not algorithms for sure, because I think this is a very subjective, this is not something that you can just standardize, you know, how a programming, this is a profession, you don't, there are a very few professions that you can standardize basically, and this does not seem to me at least to be one of them. So subjectively, what would you look for in a good, like, what do you think makes somebody a good programmer, or even, you know, as a student, I'm a student, so any sort of advice for budding programmers that you might have?
It's also a hard question. I do interviews with people that we want to hire, so I ask myself that all the time, and I never had have a good only in hindsight I can sometimes say things, and it in terms of hard skills, I think it depends on what area of software development you need somebody for. So I think that if you're a full stack developer to do a business application, I don't necessarily expect you to know 10 algorithms by heart. But for me, it's a lot more important, you know, things like curiosity, not being dogmatic, but being open to other ways of doing things, how you work with other people. I mean, it's all very high level, but it's more about attitude for me, because it's also, you were mentioning a standard in terms of hard skills. It changes every year, right? So I was actually talking to a friend recently who has been on maternity leave and is now wants to come back into the job, and she's freaking out a little bit about all the things she needs to know. And I told her, actually, it's a great time actually now, because things are changing all the time anyway, so all the people that you're going to join on a team, they're not going to know these things necessarily as well, because especially like when you're in front-end development with JavaScript changing. So if you know the things like, if you can put things into buckets quickly, like this is a build tool, this is something that I automate server installation with, you know, and then those are the things that are important.
I just wanted to add something. I think it might be simpler than just throwing algorithms or machine learning at the problem. There was this experiment where contributions to open source software, where they just hit the gender of the contributor. And then out of a sudden, the contributions from women, they were immediately more often accepted than before. That I think could apply the same for, let's say, for applicants. And if you look at resumes, if you remove the gender already, then you might already have this prejudice.
Yeah, there's some studies
removed.
around that. Yeah.
Just wanted to add that.
Nice talk.
Thanks.
But I seem to remember as a story that when they removed the gender, there was more stereotype picks in the end, because basically you're reading the remaining parts and are looking for what you expect. And I wanted to add one thing. It seems you have to learn one way or another many things to get a good software developer. And it really depends on the culture of the company, how you can teach your programmers the new stuff. Yeah. As you said, if you leave one year, you might not know anything relevant to your current project. And there are people around that are really nerds that try to learn everything for themselves, and they really set the pace. And everyone else has to get up to speed and have to learn the thing. How they do it doesn't matter if they learn it from a colleague or learn it by themselves during night sessions or weekends. It doesn't matter. So.
Yeah, it's a Berufskrankheit, right? That we always think, oh, I'm freaking out about it. And I don't know if you've heard about this term imposter syndrome, where people think, oh, somebody's going to find out that I actually don't know what they think I know. And I think a big factor, and I think that a lot of people in IT have imposter syndrome, and I think it's generally said that people in very high-performing jobs often have this. And I think one of the main reasons is that we usually just see the tip of the iceberg of what people do. So we see the things that they do good, we see the things that they can talk about, but we don't see all the work they had to put in to get there. We don't see all the things that they do not know. So, and we compare ourselves to that. So we have to focus more on the things, on our tip of the iceberg, like the things that we do know, the things and the work we put into that and where we were successful, and then share that with others as well, and all be more vulnerable about that.
And in the end, we are really suspect to the survivor bias, because we only hire people we think they might do what we expect them. But the ones we turn back, we never evaluate if they would have fitted.
Yeah.
So nobody is perfect in any sense in electing who can do the work or who cannot.
And I mean, all the stories about biases, how, you know, maybe if you take it away, it might become worse, or it's super complicated, right? But I really hope that there's a lot of noise about stuff at the moment as well, like people going back and forth and things like code of conduct, all the discussion about it. And I really hope that it's all that noise is a sign of the growing pains, that we're actually in a transition and things are happening and changing. But I hope that's true.
I also wanted to add about the tip of the iceberg, and you also mentioned magic tasks of programmers. I guess the comparison to magicians is quite valid, because magicians also have much practice. They do much practice at home or in the hidden. And now we see some magic trick, and we are all surprised, but it's only practice. It's nothing special.
It's all an illusion, right?
Yes, it's an illusion, and I guess everyone can practice, no matter if woman or man. So it only depends on time. And now it can become worse when you have too much passion. Yeah, that's the point where you, as a magician, need to think about, how much life do you want to invest?
Yeah.
Thanks for the talk.
Thanks.
So I have another question to ask. As Linda said in the morning, we do have some stereotypes, and we do like to open boxes in order to fit the people into. I was wondering whether we will somehow have an attitude towards more personalized treatment of human resources, more personalized even these fitness diagnostics, so all these more personalized services and the more personalized view on diversity, because diversity is not just the gender question, it's not just the question of age, it's not only a question of illnesses, it arises at every point, more or less. Do you think personalization might be a solution?
What do you mean by personalization exactly?
Well, you just imagine personalized medical treatment based on your, well, scientifically proved genomic profile. Or think of personalized psychotherapy, or think of personalized human resource training that makes the effort to give you an empowerment which is suited right for you.
Well, I hope that's already happening. At least like where I work, it's definitely happening. Like people are seen as individuals, and like I work for a software consultancy. So in a consultancy, you always have this function where you have to staff people onto projects, right? So and it's super complicated because you have so many dimensions. You have like the skills for that particular project, where that project is and where people live, what type of roles you need, all that stuff. And there's always one factor in there as well, what the personal preferences of the person are, what their living situation is, all that stuff. And you know, those people always try to optimize it for everybody as much as they can. It's never possible in this particular example. But that for me is just one example that I hope that you work for companies that look at you as an individual and try to push you as an individual, not as one of 100 developers.
Last question.
My question is, do you know if there's any different countries or other cultures where things are better, like in a way that's not as awful as things
I've actually gotten that question a lot after I published the interview, and I only know of one country where the number of women in tech leadership positions, like technical leads and teams, is higher than that of men, and that is the Philippines. I don't know if, and I don't know why, but that is what I know. On my previous job, I worked with a delivery center there once, and I also have heard it confirmed in other sources. So, if you know any other countries where it's different, then yeah, maybe let me know. But
so I'm in this panel where we try to get more women into IT at my university, and one of the things we found is that I think it's Malaysia, where there are more women in the IT industry in general, a lot more women, because it's looked down upon, because real men do labor outside.
Oh, interesting.
So in the countries where it's looked down upon, it's really that we have a lot of women. And that's also what it used to be like I'm from Denmark in the old days, because it was just a typing job. And but then when it became a prestigious job, men came in.
From coders to programmers. Yeah. Interesting. Okay. Thank you very much, and have a great rest of the day.